Now that we've learned a little bit about how we can use the visual programming environments to manipulate numbers mathematically, as well as to create a little bit of basic geometry, let's think about how we can apply this to actually start manipulating model geometry in an environment like Revit. So we're going to look at a couple examples here. The first one's going to be just creating a basic sine wave using the Dynamo environment. And for the next example, we'll be looking at how we can then use those sine wave values to actually determine the heights of some different towers that we might be placing on the landscape. So in this example, we're going to look at 3 different steps. First, we're going to create some different x, y, and z values that'll create a list of points that will connect together in the second step, okay, as a curve. And then in the third step, we're going to be adding a little bit of a flexibility so we can manipulate that curve to really make a kind of more pronounced sine wave. So in this first step, again, we're going to create some x, y values. Here, we're just going to use x values using a sequence. We'll generate some different x values and maybe kind of use a number slider to indicate the y values. Then we're going to go through and compute some z values using a sine function, using the math sine function. So looking ahead to what this looks like, we have some x values over here, we have some y values over here, and basically these x values are just going from 0 to 360. We're using those really as angle measurements that we'll compute sines for. We have some y values, and then we're going to use the math sine function, okay, just to kind of take those angle values and compute some different values that'll range from -1 to +1. Now, after we compute those basic values, we want to basically create some points out of those x, y, and z values and then connect them together using the NURBS curve by points node. So back over in the example, you can see we can take the x and the y values. The z values are coming out of this lower part. Originally I had just math sine, but we're going to do a little enhancing to that. And then we have the x, y, z values here being fed into a curve. That's what we're seeing up here. And then finally, in the third step, we're going to go through and just add a little parametric flexibility to allow us to kind of just change the wave easily. So we'll set up some different number sliders for the amplification of the wave, maybe giving us the ability to increase the number of waves and even adding a base offset so that it's not down at 0, but we can raise it up off the ground a little bit. Okay. In order to go ahead and incorporate those, I'm going to use some code blocks, and I can either do it as a series of code blocks that will link together, or as a single code block if you want to be ambitious and put it all together just into a single chunk of code. You'll see that over here. Here are some sine wave parameters for the number of waves, the base offset, and the amplification factor. Okay, and over here, we're basically using some code blocks to basically multiply the angle value by a number of waves, then do the sine of that, and then finally adding the base offset and kind of amplifying the wave here. So what is the net effect of all those? Well, let's just go ahead and see. So if, for example, if I turn down the amplification factor or raise the amplification factor, you can sort of see we can make the wave much wavier. We can go through and give it a base offset. That's just going to raise it up or down in the z direction. That might be important to us if we're using these to actually determine the heights of some geometry, because things don't like to have a 0 height or a negative height when we're creating objects. We also have a factor here for the number of waves, and that's just going to scale things out. If you bring that down to all the way to 1, it's a single wave in the distance. If I raise that up, I get more and more waves or denser waves. Okay, so that's an overview of the example. Let's go ahead and get you started with it.